Hi, it's time for a chime video. So today we have a Rittenhouse Model 410 8-note long tube door chime. This particular one happens to be from 1952. Models like the 410 have a unique problem that today we're going to try to solve. Pretty standard design, big rectangular metal box that gets screwed to the wall. You've got 4 adjustable tube hangers. You can thread them in and out, make them closer or further away from the 4 plungers. This is an 8-note Westminster chime. There is no provision as it is right now to play only 4 notes. And you have a volume control here which adjusts how hard the plungers pop out and strike the tubes. Problem with the 410 is this. This is what's called a dashpot. Now, I know for some people, you might look at this and think, hey, that's some kind of big, giant metal encased capacitor. It's not. It's a mechanical device. In fact, if you listen carefully, you can hear the innards move back and forth as I shake it up and down. So what is a dashpot? Well, this was Rittenhouse's idea, I think, on how to simplify, perhaps, the construction of door chimes. These things are very complicated in what they do. So what's inside this? Well, this is an electromagnetic hydraulic device. There's an electromagnetic coil inside with a plunger. The whole metal body is filled up with oil. There's a metering valve for the oil. So when it's energized, the plunger pulls up through the oil, compresses a spring, and then when it shuts off, the metering valve regulates how fast the spring pushes the plunger back down through the oil, making connections which are plugged into the chime to make the plungers pop out and strike the tubes. Could you have thought of anything that would be more complex than this? Probably not. I've seen one other chime, which someday maybe I'll do a video about. It was a General Electric chime. It was from the 1930s that was easily 50 times more complicated than this. The reason I think these existed is because if you open this up, and we'll put the back off to the side because we don't care about that. Here's the inside. The inside is very simple. You've got 4 solenoid assemblies with plungers. You've got a little bit of wiring. You got a rheostat here for the volume control. You got some screw terminals on the front. And then you've got this multi-pin wiring harness connector. And this simply was designed to plug into the dashpot. And then it gets bolted into this strap thing like this. So if you were building door chimes, you would order a whole bunch of these from whichever company made them, and I don't know, maybe Rittenhouse made them in-house. I don't really know. And there isn't anyone to ask, so it's all lost to time. But if you were making this, you have this assembly, you make up a wiring harness, you sort of screw everything together, do a little bit of soldering, and then you simply, instead of soldering a whole bunch of individual wires on all kinds of little individual pieces, you simply take the dashpot, you plug it in, you pop it in the bracket, screw it down, and you're ready to go. Sounds great, huh? Well, it's not great, because these things fail all the time. In fact, it's sort of a given that this will fail at some point. And I think it was enough of a problem early enough on that they only used these for about, near as I can tell, 3 or 4 years before they were discontinued. And I assume at some point you could still order replacements from Rittenhouse, but they've been out of business since the early 80s, so that's not an option anymore. The fellow that owns this chime, he wants me to fix it and make it work again. So how are we going to do that? Well, we're going to make a hybrid out of it. I'm going to put the dashpot off to the side. Oh, and by the way, there will be an extensive video about the dashpot, because when I get this job done and get it back to the customer and he's happy with it, then we're going to take this and we're going to cut it open and I'm going to show you what's inside. So that should be an interesting video. So what are we going to do with this? Well, we need to have some way to control the solenoids and create a Westminster chime out of it. And the easiest way to do that, I think, will be with this. This is an electronic 8-note chime board from a NuTone door chime. This happens to be from an LA70 MA that was made around 1995. And this is actually brand new. It's new old stock. It's a new old stock chime, been sitting in the shelf in the back of the parts room for who knows how long. I scavenged it out of the chime. I did test it before I took it out to make sure that it actually did work, because sometimes new old stock stuff is sitting on the shelf because, oh wait, it doesn't work. But this one does. We're going to do a little refurbishment on this. There's a few capacitors and things that are going to get replaced just because it's been sitting on the shelf for 30 years. 1995, 30-year-old board. Still works great. So we're going to take this and we're going to install it in this. Actually, what we're going to do is we're going to install it in the back box part of this. We're going to sort of bias it up towards the top because we need to stay out of the way of the solenoid assemblies. Yeah, I don't think it's going to be that hard to do. There's plenty of wiring in here, so we can wire this board up to the terminal connections here, so that'll be fairly straightforward. Some of the considerations are going to be, what are we going to do with the volume control? I don't know. I haven't gotten into the nitty-gritty details of this yet, but this board has a volume control pot on it built in, and I don't really want to. I suppose I could line it up and then drill a hole through the front, and you could put a screwdriver in and turn it, but I don't really want to drill a hole in the guy's chime. I might be able to install it this way, which would be technically upside down, like this, upside down. The danger in doing that is all of the electrons might fall out. But I think I might be able to line it up where if we take the volume control off here, there will be a hole through the front of the case where if I get it lined up correctly, you could slip a screwdriver in and make the volume adjustment. So that could be probably a tricky way to do it. Other than that, I don't think it'll be much of a challenge. Now, one of the things to consider is, and this gets overlooked to some degree, each one of these has an electromagnetic coil in it. And the resistance of the coil has something to do with how hard the plungers strike, because the lower the resistance, the more current it draws and the harder strike you get. Now, the voltage varies with the volume control here, and that plays into it also. So I do have to measure these and see where we are. But because this board has driver transistors to activate the solenoids, unless it's way, way, way off, I don't think it's going to be a problem. Let's take a quick measurement and see kind of what we have. Get the meter set up there. I haven't done this yet, so let's see. 1, 2, 3, 4. That's probably the common. So we got 11 ohms, 11 ohms. That one's 16 ohms. That's kind of way out there. And that one's 6 ohms. So that may not be the common. It'll take a little bit of investigation. 11, 11. Looks like 11. Looks like the white one is the common, which is kind of odd. Anyway, so 11 ohms. That's good because in a NuTone chime, the solenoids are usually somewhere between 10 and 12 ohms. So very similar resistance here. So that should balance out nicely. The real trick is we need to get the board mounted in the base. It needs to sit on standoffs because you got solder points on the back of the board, and of course we don't want to short it out against the metal case, so it's got to stand up off the back just a little bit, and we'll make an insulating card to cover it up also, just sort of like belt and suspenders there. So there's all of that to do, and I think what we'll end up doing is soldering in all the wires, make it all a permanent installation so the customer can just use the terminal strip on the front. This will be the first section of this video. Once I get some of this figured out, and you know, in some respects this is more of a mechanical thing than anything else to do, is mount it and put it all together, but we'll see how it goes. Anyway, I'll be back. Hi, I'm back. So our Rittenhouse 410 project actually I think turned out really well. We'll find out at the end when we try it out again. What I did was open this up. I mounted the NuTone control board into the back of the box of the chime. I made these little nylon standoffs so there's some space under the board so it's not sitting right against the metal, of course, because that would short it out. I also made a cardboard insulator that sits behind it just to extra protection that way. I was able to place the board in a location that when you put the cover back on, you put it all back together, you can use the opening that's left over from the original volume control with an appropriate size screwdriver to adjust the volume setting on the board. So that worked out pretty well. And I simply made up a wiring harness for it. We have on the back of the terminal strip here, the orange and yellow wires are the power wires. So you have common and trans. And then the next two, it's set up as a two-door chime, front door, rear door, because that's how many terminals we have. So the gray wire is front and the green wire is rear. So 8 notes or a single note. And then the other thing I did was I made up a second wiring harness. So the twisted wires are the connections between the terminal strip and the board, and they actually go underneath the board down. It's a little hard to show exactly, but the screws where the wires would normally get connected are down in the slot down here where you can't really see. And what I did was I stripped the wires, twisted them tight, bent them into hoops or hooks, and soldered them just to make them sturdy, and then put them back under the screws that would have been originally used in the NuTone LA70. So they're very secure, and they are also insulated with the cardboard, and they stand off the metal plate. The other 4 wires or 5 wires down here, we have a little hard to show. Do it this way. So these are the connections for the solenoids. So brown is common, then you have yellow, gray, orange, and green, and they're soldered to the connections on the board where the original NuTone solenoids would have been soldered, and then they simply go down to the terminal strip down here on the solenoid block assembly, and that's it. It's a pretty good setup, I think. It's important to put the cover back on the right way. Put it all back together. We'll put the 2 screws that hold the cover to the base. The way this would get installed is the base goes on the wall first, you screw it to the wall, and then there's a hole right here, which is where the wiring from through the wall would come into the chime, and then it needs to be connected to the terminal strip also. So you would bring it out through this hole in the front, and then it gets hooked up to the 4 screws on the terminal strip. That's pretty much it. I did not have to modify the front of the unit at all. The volume control is gone, so there's a hole, but that works out for the volume control on the circuit board. And on the back side, I did have to drill 4 holes to put mounting screws for mount the board and all of that. But all in all, it's a minimally invasive and reversible thing, I suppose, if you ever wanted to. What I'm going to do is I'm going to hook this up on our testing jig. I'm going to put some tubes on it, and we're going to ring it and see what it sounds like. All right, let's see how our handiwork turned out. I have it set up on our testing jig. These are 4 NuTone brass tubes, number 1, 2, 3, 4. Actually, it's 4, 3, 2, 1, but regardless. This one, these are original NuTone tubes from the 1950s. This one has a slight crack in it, so it sounds a little off, but you get the general idea. So we have it. I have it set up for an 8-note front door ring and a single note side door ring. So we'll do the side door first. That was 3 button presses, and then we'll ring the front door. Just as you expect. So I think our hybrid chime renovation project turned out pretty well.